I know. How about that? It's a new little packet. Okay. All right. So here we go. So remember, oh, I got to turn the right page on my key here. I did. Thank you. Thank you. Thank you. Yeah, I'm pretty good about it in college algebra, but I think it's because you remind me, but the other classes I'm not so good. Okay, so we want to write the equation of the parabola. So anytime they tell you that they want an equation of the parabola, what you need to be able to do is write it in standard form, because otherwise it's just impossible to write. So if we remember, that's standard form. So that's what we're trying to find. Okay, then they give you some information. The first part of the information is a little strange. So they tell you it has the same shape as the graph of either this one or this one. Okay, what in the heck is that about? That's giving you the A. That's what they're telling you, that the A is either going to be +9 or -9. That's what they're telling you. They're giving you two choices for your A, that there's some kind of vertical stretch. It hasn't told us yet if it's going to be opening up or opening down. We still have to find that out. But they're telling us that A is either +9 or -9. Okay. All right. Then they go on and tell us that it has a maximum. Okay, now we're getting somewhere. So if it has a maximum, is it opening up or is it opening down? Down. Okay. Why do we know it's opening down? Maximum sounds like it should be going up, because there's a maximum point where it changes direction. So if it tells you maximum, it's opening down. If it tells you minimum, it's opening up. Okay, since it's opening down, now we know exactly what our A is. Is our A going to be a +9 or a -9? A -9, because we're opening down. So now we're able to use that first piece of information. Does that make sense? So it's kind of like your little detectives on a detective hunt. Okay, so there we go. We're opening down. We have an A of -9. Okay, perfect. Then it tells us where the maximum is located. What is this information giving us? It's given us our vertex, right? It's given us our H and K. So let's think about how they wrote this. They said the maximum equals 5 at x equals -2. So what is our vertex if we write it as an ordered pair? -2, 5. We take it right from there. Good. So this is our H, this is our K. All right. Does that make sense? Took it right from there. All right. Then it wants the formula. Now, I know that they used h of x, which is confusing because we have an h, but it's only because they'd already used f of x and g of x, and they're just going in alphabetical order. They just want the equation. This is what they want over here. Okay, so we know our A is -9. Okay, x. Now we have to do minus h, but our h is -2. So we'll do a +2, square it, plus k. And there's our equation. Okay, is that good for everybody? Okay, now there was a question brought up yesterday that was a super good question, but I don't think everybody heard it. So I'm gonna flip this over real quick and bring it up to you, and then I'll flip that back in case some of you didn't get that. Okay, so let's go back to the other page, and just, if you don't want to flip back, you can just watch, but let's talk about this one a minute in the middle here. Okay, so we talked about the fact that if you're given an equation in standard form and you need the vertex, you have to take the opposite of h, but the same sign of k, right? And we did that really well. Then we said if you're in general form, you're going to use this formula to find h, plug it in to find k. So because I stressed so much to use the opposite of h with this formula and the same k, it seemed a little confusing as far as once you get this, do you need to change the sign or do you need to do anything else? No. Okay, so if you're pulling it out of standard form, opposite h, same k. if you're finding H using this, whatever you get is your H, as is. And then you plug it back in, and whatever you get for K, that's your K as is, okay? So we only change the sign if we're pulling it out of the standard form. Does that make sense? Okay, all right, so let me go back here. You might not have been finished with that when I changed the page on you, but there he is. Okay, so we made our equation. We had our information. We went from there. All right. Okay, so you were detectives. Now you're going to be farmers. Okay, let's put on our little farmer hat. All right, we got to help Farmer Ed. Farmer Ed has a lovely farm down by the river. Okay, so I know this is probably hard for you to see on yours, but here's the river. This is a river. Okay, and he wants to fence in a little plot of land. He wants to grow some vegetables, right? Something right here on the river. This is the deal. Okay, he has 200 meters of fencing. I don't know, maybe he's in Canada. I don't know how to use meters, but we'll just go with it. Okay, so he has 200 meters of fencing. So he wants to enclose this little rectangular plot on the river. Now, since he's on the river, he doesn't need to fence the river because he's just growing vegetables or whatever, right? So he's going to take his 200 meters and he's only going to have 3 sides of fencing because he's going to use the river as his other side. Everybody got me? Okay. All right. So luckily they went ahead. You don't have to do anything with the 200. They went ahead and gave you some different little sides already. They told you that each of these sides is going to be X, which means we don't know how long it is, which means this side is going to be 200 minus 2x, because it's, 200 is what he has minus the 2x's he used for the sides. That's what that one. Okay, so they gave you that information. You didn't have to come up with it. All right. So what we want to know is, okay, we want the length and the width. Okay, so here's the width. The width is X. They tell you that just in case you're not sure which one is length, which one is width. So they give you the width, it's X. They give you the length, it's 200 minus 2X. They want to know what are these values that's going to maximize the area. What's the biggest plot he could possibly make? Then, once you find that, they want the area that's inside the plot. That's what they want. Okay, which sounds really complicated and ridiculous. But again, parabolas are pretty nice. So all this means the length and the width are the vertex of a parabola, believe it or not. That's all they're asking you is the vertex of the parabola. Okay, so pretty nice. Okay, then the largest area that is enclosed there is actually the y coordinate or the k of the vertex. So I guess I should say this is the h of the vertex, or the x coordinate of the vertex is what they're looking for there. Okay, and then you plug that in here to find the length. So that's what they're asking for. Okay, so here we go. All right, first we need an equation so that we can find the vertex, right? Okay, well, we know we're trying to find area, and we have, where does it tell us? Right here, a rectangle. What's the area for a rectangle? Yeah, okay, length times width, base times height, whatever you like, you just take the two numbers and you multiply them together, right? That's what we're looking for. Okay, so we're gonna have these two numbers multiplied together. Okay, now you don't have to write them like that. You could write them like a normal person writes them, but I was just trying to remind you the length is this, the width is this. You're just going to multiply them together and you're going to distribute. So if you want to reverse this, you certainly can. Okay, so our area is going to be 200x minus 2x squared. Okay, this area, which is what we're going to find down here, which is the answer, is actually going to be y, or f of x, or whatever we want to call it. So let's call it f of x. And we're going to rearrange this so that it's nice, really nice descending order. Okay, so we took our area from our little plot and then we rearranged it And now we have our equation. Now I know he's a weird equation because he doesn't have a constant, but he's still a quadratic equation. So he's still a parabola. And then let's think about this. Is this parabola opening up or down? It's down, but if it opens down, what does it have at the very top? A maximum. So anytime you're asked to maximize something, you're finding the vertex of a parabola that opens down. If you're asked to minimize something, like minimize the cost of something, you're finding the vertex of a parabola that opens up because you're finding the minimum, okay? All right, good. So now that we have this, we can find our vertex. Now he's not in standard form, unfortunately, but we know that we can always do opposite of B over 2A, right? To find our H. That's our X coordinate, okay? So what would the opposite of B be for this? Negative 200 over 2 times A, which is negative 2. Okay, if we work through that, we're actually going to come up with negative 200, or I'm sorry, 200 over 4, which is 50. Okay, so this is H for the vertex. It's also the X coordinate and the X from the picture. That's what that is. So it turns out we can come up here and write in 50 right there. This is going to be 50 meters on each side. We found that. Everybody okay with that? All right. Then we can also find this guy. How can we find him? Plug him in, right? So I can take this guy and do 200 minus 2 times 50, which is going to end up giving me 100. That's perfect. Everybody see that? Just plugged it in. Now, this is going to be great because we already knew that Ed had 200 meters of fencing. So if this is 100 and this is 50 and this is 50, that's perfect. He used it all. He totally maximized his area. Now, the next thing we want is the largest area that can be enclosed. This is K from our vertex. So we already know 50 is our H, okay? So we can now take that and plug it into this equation to find K. So if I take negative 2 times 50 squared, plus 200 times 50, that's going to give me, 5,000. And of course, that's meters squared or square meters. So that's what's going to go here. Now, if I didn't want to do that, there is another way I could have done this. I already know this side's 50 and this side's 100. How do you find the area? Multiply those together. So I could have done 50 times 100 and gotten 5,000 that way, okay, from my picture. So I used the information they gave me. I created an equation using area, length times width. Then I used how to find the vertex to find the X coordinate of my vertex, which was also the X from the picture. I plugged it in so I could have all my sides. Then I went back and plugged 50 into the original equation to finish my vertex, to find the K, to get the 5,000. That's the maximum area. Or I could have just multiplied 50 times 100 and got it that way too. Is that okay with everybody? Okay, so you'll have Farmer Ed on your My Math Lab. When you get to him and he's got the river, flip over here to page 5, right? Okay. All right, are we good here? All right. Okay, so now we're doing track and field. You're no longer farmers, you're athletes. Here we go, okay? And your event is the shot put. So I don't know if you know what that is, but it's like a ball. I don't know how big it is. I figure it's like a softball, I don't know. But it's really heavy, it's like solid. And what they do is they put it up on their shoulder and they like spin around in a circle and then they throw it, right? And then however far it goes, that's what they measure. That's the shot put. All right. Yeah. Okay, so when the shot whose path is shown by the graph right here is released at an angle of 35 degrees, its height in feet can be modeled by this equation. All right, we don't care the height. This is not trig, I'm sorry, the angle. We don't need the angle. All we need is the equation. That's the key. We want the equation. And it turns out they already gave it to us. Farmer Ed, we had to make our own. The shot put, they gave it to us. It's ugly, it's not pretty, but we have one. And this is our graph. So I know it doesn't look like a parabola, but just imagine it's coming down. Just imagine it has peaked at the top and it keeps on coming, okay? So we have a maximum point somewhere around here. I mean, you can't really tell from the graph, but that's kind of, everybody see what I'm saying here? Kind of right there. All right, so X from your equation is the shot's horizontal distance in feet. So if you look, this is how far the shot put went. I don't know, it's not quite 80, it's like 70 something, 78, so something like that, okay. And then here's the height where it was released. Now, why wasn't it released at 0? Well, because it's not a ball on the ground that you're kicking. If it's soccer, right, and you're kicking the ball, it would start at 0 because it's on the ground. But where does the shot put start? On your shoulder. So the taller you are, it's the higher it is, right? So that's why he's not down there at 0, because whoever's throwing it, this is the height of their shoulder. And then it goes up, okay? All right, so use this model to solve parts A through C. Okay, well, here we go. Let's read what they're asking for and then see if we can figure out how to find that. So first of all, it wants the maximum height of the shot. So what does that sound like? Vertex. Maximum height of the shot, the peak right here. And sure enough, our equation's negative because we're finding the max, so it's going to open down. And so the maximum height and how far from its point of release does this occur? This is just the vertex. This is the H and the K of the vertex, okay? So that's what we're going to find there. All right, well, let's go ahead and do that, and then we'll move on to B. Okay, so we have this nice little equation. I'm going to write it over down here so I can mess around with it. This is probably the yuckiest problem just because it's got decimals and it's not real nice, you know. No, just my math lab. Yeah. Okay, so now we need the vertex. Now remember, he's not in standard form. So how are we going to find the H coordinate of the vertex? Good, negative B over 2A. Okay, so our B is 0.7, so we're going to do negative 0.7 over 2 times A, which is negative 0.01. Okay, put that in your calculator. You should come out with a very nice little 35. Does that sound right? Check it and see. That's what I came up with. Okay. Oh. No? Okay, let me do it in here. Oh, okay, I see what you may be doing. Okay, so when you put it in, okay, negative 0.7 divided by, you need to put in parentheses the 2 times negative 0.01. There's your 35. So here, this could be what's happening, and I want to make sure that I clear it up real quick. If I do negative 0.7 divided by 2, well, let me do this again. Negative 0.7 divided by 2 times negative 0.01, that's not 35. Why did it not come out? Because your calculator follows order of operations. So you know what it did? It divided these two, came up with the answer, and then it multiplied your answer times negative 0.01. So you can't do that. You have to either put the whole denominator in parentheses or divide each one separately. And then you get the 35. Make sure when you have more terms in the denominator, you divide every single term. Don't hit multiply, okay? Because your calculator will take it literally. All right, so now we have a 35. That's perfect. Now, how do we find the K coordinate? You plug it in. So we're going to come up here, right? And we're going to plug in 35. Now, this is super yucky, but we're going to do it. One little piece at a time. Right? I'll go ahead and tell you the answer is going to be 17.35. Okay, there we go. So that means my vertex is 35, comma, 17.35. Now, it never hurts if you have a picture, go to your picture and ask yourself, does that make sense? Okay, so we said our vertex is somewhere about here. I mean, it's really hard to tell. But that looks just about 35, and it definitely could be a 17.35. So that's reasonable, right? Okay, now we have to figure out who goes in which spot, because that's confusing. So the maximum height is this, which occurs blank feet from the point of release. All right, so which one would be height? 17.35. Good. Now remember, height is y, so it's always going to be the y coordinate, but also if you look on here, you would be able to figure that out. So this is going to be 17.35, and this one's going to be 35. Good. Okay. All right, now this is the stinky part. If you thought that part was stinky, I'm sorry. Okay. All right, B. B wants to know, what is the shot's maximum horizontal distance to the nearest 1/10 of a foot? Or in other words, the distance of the throw. So if I go up here, what's the maximum horizontal distance? What's the farthest it went? Yeah, something right here, right? But we're not super sure. We certainly can't go to the 1/10. So how are you going to find this? What is this? It's touching the x-axis. So it's a x-intercept. And if you were to flip back to the beginning page, how do you find an x-intercept of a parabola? You plug in 0 for y and you solve. Remember, we talked about the fact that you guys didn't know it. You've secretly been finding x-intercepts your whole life. Quadratic formula, factoring, when you solve it, you are finding the x-intercepts. So that's why this problem is stinky, because you have to solve it for the x-intercepts, okay? Now there's only one, so that's what we should be looking at. But when I look at my equation, how many answers am I gonna come up with? 2. Okay, then we're gonna have to use our skills of deduction, right, to come up with which one is right. All right, well, I don't know about you, but I can't factor that. That's just beyond me, and I don't want to anyway. So what's our only other choice to solve him? Quadratic formula. Okay, that's why he's kind of stinky, because I know we're all lazy and we don't want to do it, and we certainly don't want to do it with decimals, but here we go. Okay. Right? We're all, yeah, I know. Okay, so let's go through here real quick. Let's see, our A is negative 0.01. Our B is 0.7, and our C is 5.1. All right, and then I'm not going to write out the quadratic formula. We'll just talk about it as we put it in, because I'm already running out of room. But x equals, so we need the opposite of b, the negative b, plus or minus square root of b squared, so 0.7 squared, minus 4a, I'm out of room already, c. Yeah, there, kind of ran out of room. All right, what's going to happen to this term here? Is he going to be added or subtracted? Added, right? You would expect him to be added because it's minus a negative, so keep that in mind. And then the whole thing is over 2a. Okay, so that's pretty stinky. So you're just going to have to take it one little step at a time. Let's go inside and handle that radicand. So if I do 0.7 squared And if I multiply this together, I don't know what that is, but then I add them together, I'm going to get underneath my radical I think it's 0.694. And that's all going to be over negative 0.02. Okay, if I multiply that at the bottom. All right. Now all I want is an answer in decimals. So we're just going to put this right in our calculator. The square root of 0.694 comes out to be 0.833. The whole thing is still over negative 0.02. Okay, we've never really done a quadratic formula like this because we've always been so careful to leave the whole numbers, right? And just reduce it the best we can. So I don't think we've ever done anything like this in intermediate or college algebra, but we're just trying to get a decimal answer. So you're just plugging and chugging. You guys ought to like this one. You don't even have to think. All right, now we've done all we can do. We're going to split it. What you got? Oh, thank you, Lacey. Yes, that would have messed me up. Negative 0.02. Thank you. Okay. All right, I've gone as far as I can. Now I have to separate them because this is a plus and a minus. Everybody agree with that? All right, so I'm going to go over here to one side and I'm going to do negative 0.7 plus 0.833. Once I find that answer, I'm going to divide it by 0.02, negative 0.02. Then I'm going to come over here and I'm going to do one minus 0.833 over negative 0.02. Okay, I have to do both of them and I have to come up with my answers. Is everybody okay with that? All right, so this one is going to give me an x of 76.65. This one's going to give me an x of negative 6.65. Okay, because we said we were going to get two answers, right? Okay, now we have to think. We have to use some common sense here. What we're trying to determine is the maximum horizontal distance that the ball went. So do we think it went negative 6 feet? Or do we think it went 76 feet? Yeah, you can't, I mean, I could probably throw it and get a negative number, but most human beings are going to throw it and get a positive number, right? So it's not going to be negative because we're finding a distance. And then we also said we could go back to our picture and see what looked right. And you guys already told me you thought it was like 76, 77, 78, right? You thought it was around there. So this makes sense. Okay, this wants it rounded to the nearest 10th. That's one decimal place. So we're going to make 76.7 feet our answer. So that was really stinky. That was the worst one you'll have to do. No, you can't throw it negative, right? So you just cross it out. It's just one of those extraneous answers. It's just an extra answer. Mm-hmm. That's right. Yeah, we got to find C now. Okay. Wow, there's only one of the shot puts. How's that? Of the shot puts. Oh, okay. Yeah, it's only one like this. Thank goodness. All right, last one. From what height was the shot released? Okay, so we already said it wasn't 0, that it was however tall the kid is throwing it, right? His shoulder height or her shoulder height is what we're talking about. So we're right here. So that's on the y-axis. So what are they really asking for? The y-intercept. Now to find the x-intercept, we plugged in 0 for y and we solved it, and it was horrible. To find the y-intercept, you're going to plug in 0 for what? X. That's not bad. Okay, so that means I'm going to take this equation and I'm going to plug in 0 for x. Okay, so if I find f of 0 and I plug in 0 and square it, and then I plug in 0 here, what am I left with? 5.1. 5.1. You didn't even actually have to write it out, right? And it's already rounded to the 10th. That's the kid's shoulder. And if you look at it, that makes sense. It looks about 5 right there. So that's your answer. Okay, so they're really asking for the vertex, the x-intercepts, which are the solutions, and the y-intercept. That's all they were asking for, but they never said it. You just had to figure that out. So that one stinks, but it's done. That's the worst one. You survived. Or that's an option.
I still get a 90 something.
Okay, so are we good on that? Not real bad, stinky one? Okay, it gets better, I promise. All right, now we're back to a doable one. Okay, so we're told a parabola opens down. Fantastic, love that. It has a vertex right here at -3, -2. What's the domain and range? Now, let me warn you, one of the MyMathLab problems will say exactly what I just said. The other one will give you this information. It's going to say the parabola has a max at -2, x equals -3. It's the same information, it's just told to you different. So I just want to make sure you realize if it tells you it has a max, you automatically know it opens down. And then if it says the max is at -2, x equals -3, make sure you write your vertex correctly, okay? No matter which way they tell you. All right, it wants the domain and range. What's the domain of every parabola in the whole wide world? Good. Okay, interval notation looks like that. Perfect. Now we want the range. So remember, the range always has one of the infinities with a parenthesis and then the y coordinate with a hard bracket. So let's figure out what order they go in. For this guy, where does he start? -infinity. There's your parenthesis. And where does he end up? At -2 for the y's. And remember, that means a hard bracket because we're including it. Good. Okay. All right, last page of these. Yay, they're not terrible. The first one's going to go quick, and then we got to help Farmer Bob. We got to go back to farmers again. Bob doesn't have a river, so he needs 4 sides. Okay. All right, here we go. We want to write an equation in standard form. Fantastic. We totally know standard form. Remember, it looks like this, just in case we need a reminder. Okay. And it says the parabola has the same shape as the graph of 7x squared. Now we'll stop right there for a minute. What does that mean? What information does that give us if it tells us it has the same shape as that? It's a parabola. And if it has the same shape, it's either going to open up or down, just like this guy. So what is he going to open? Up. And it's also, because it has the same shape, going to have the same A. So what's his A? 7. Okay, awesome. So I'm already putting down some information here for my actual equation. I'm just going to steal his A. That's what that means. Okay, my A is 7. Then it tells us that it wants a vertex of 1, 9. So remember, that's H and that's K. And since we're using standard form, we're going to put in -1, good, plus 9. And there's our parabola. That's it. We can do that. Sound good? Okay. All right, let's help Bob. All right, we got to do an extra step for Bob since he doesn't have, a picture drawn. He didn't tell us anything about X, all that good stuff. He doesn't have a river. Okay, so Bob has 280 yards of fencing and he wants to enclose a rectangular area. Find the dimensions of the rectangle that maximize the enclosed area. Okay, what is the enclosed area? So it's asking you for the dimensions of the rectangle. Hopefully you remember that's just going to be the X coordinate or the H of the vertex, right? And then we're going to find the Y coordinate. Okay, and then the enclosed area is the Y coordinate or the K of the vertex. That's what it's asking for, just like with Farmer Bob, or Ed, Zed. Okay, so we also know that we want to maximize. So we're going to write an equation for a parabola. Is it going to open up or down? It's going to open down. So do we expect when all is said and done, our A to be positive or negative? Negative. Keep that in mind. Okay. Now he says he wants rectangle. So let's draw a rectangle and figure this out. There's our rectangle. Okay. So let's call these sides X because they're horizontal. We know they're the same side, so we can say they're each X. All right, let's call these little dudes Y. How about that? Everybody comfortable with that? Okay. All right, our first step to getting our equation, we can't multiply these together and get an area because we have two different letters and we don't know how to solve equations like that yet. So the first thing we're going to do is find a perimeter because we know that all these sides have to add up to be what? 280. So if I do X plus X, that's 2X, plus Y, that's 2Y, and they have to add up to be 280. We know that. Okay, now do you remember back on Farmer Ed, the reason this works so nicely is because he had X's, but he didn't have Y. What did he do instead? He put Y in terms of his total amount, his perimeter, and X. So that's what we're going to do. We're going to take Bob's little coordinates here, and we're going to keep our X, but now we need to change this, and we need to make Y in terms of X. So what we're going to do is solve for Y, okay? So we're going to solve for Y. So I'm going to have 2Y equals 280 minus 2X. I'm just subtracting my 2X to the other side. And then I'm going to divide everybody by 2. And I learned that Y equals 140 minus X. Okay. Everybody okay with that? All right, so I can actually go up here now and say, actually, I'm going to change this. And now everybody's in terms of X. And I just crossed out each Y and I said, that's 140 minus X. Okay, so I found the perimeter, but all it did really was let me write the whole rectangle in terms of X. Does that make sense? Now I'm where I started from with Farmer Ed. Go ahead. Oh, sure. Okay, you could have written out X plus Y plus X plus Y equals your perimeter. And then I had 2X plus 2Y equals 280. I just skipped a step. I just found the perimeter. Yeah, no, that's a good question. Okay. All right, so now we're exactly where we started with Farmer Ed. Now we have our sides in terms of X. So now we're going to find our area. So we already said that the area of a rectangle is length times width, right? We already said that. So our area is going to be X times 140 minus X. We're just trying to get our equation, okay? And so this is going to give us a nice little equation of 140X minus X squared. I can always write that over negative X squared plus 140X. There's the equation for the parabola. It's got the X squared term. We know we're maximizing because our A is negative. We're good to go. Okay. So this one was harder because we had to make the equation. We had to find the perimeter and rewrite Y. All right. Is everybody okay there? Okay, so then we're ready to answer our questions. We're ready to find the vertex. Okay, so here we go. Now we're going to find the vertex. So we know that in order to find H, it's negative B over 2A. And here's our equation we're going to use down here. So if B is 140, negative B is negative 140 over 2A. A is negative 1. That's going to give us an X of 70. All right. Well, that gave us a huge amount of information. We now know every side of the rectangle. So we know that this is going to be 70 yards. This is going to be 70 yards. What's 140 minus 70? 70 yards. 140 minus 70, 70 yards. It's actually a square. And that's a really good point because we wanted a rectangle, but we wanted to maximize our area. It turns out that to maximize the amount of area in a rectangle or any four-sided figure, a square is going to give you the maximum area, the biggest bang for your buck. Okay, so we found all of these. So the dimensions of the rectangle are simply going to be x equals 70, right? Or every side is 70. Okay, now we want the enclosed area. So the enclosed area is just k. So we can do 70 times 70 and find out that it's actually 4,900 square yards. Or we can go back down here and put f of 70 in. However you like to do it, and you're going to find out that this is your maximum area. Okay. Sometimes if I have kids that are in agriculture, they already know this. Like had Chandler Pierce, I don't know if you know Aubrey, but that's her brother. I had him in here and his job was to build fence on the weekends. That was one of his jobs. And he read the Farmer Ed problem and knew the answer immediately. He read this one, he knew the answer immediately. He never had to do the math because he just knew if you have amount of fence and all they don't care about the dimensions, they just want the biggest fence possible, you divide it by 4 because a square is going to give you the maximum area every single time. And so he found it. So that's kind of one of those things that, you know, you guys are always asking me, how do you, this has nothing to do with real life. Well, you can all build fence now, so you're welcome. Okay. I mean, he never knew he had a parabola problem in his brain, but then he knew. Okay. All right, so there's that. Everybody okay with that one? All right, so we're gonna start the next section. Yay. It won't be hard. You'll like this one. It's a lot easier. There's no word problems. Okay, so we're no longer with the farmer Bob and Ed, but you're back to being little detectives. So this whole chapter is, if I give you an equation, can you tell me what that graph looks like? And I mean, I'm really a math nerd at heart. And so I think it's really cool that you can look at it and describe what's happening without even seeing a graph. Okay, so you may find out you're secretly little math nerds too. We'll see. Okay. All right, so first thing we're going to do is just define polynomials. So polynomials are just the sum of terms where all the variables are raised to positive whole number exponents. Okay, that's why we like polynomials. It doesn't have funky stuff. We don't want any negative exponents. We don't want any fractional exponents. We don't want variables in the denominator. We don't want variables under a radical. We just want nice normal numbers. Okay, that's all we want. So then you get to play the little game on my math lab called, is this a polynomial or not? Okay, so all of these are polynomials because they're just all nice normal little numbers. Did I break it so that you pay attention? I think I might have. I gave you bad juju. Okay, so not a polynomial. Why isn't this guy a polynomial? Negative. Okay, why isn't this guy a polynomial? Fractional. Why isn't this guy a polynomial? It's under a radical. Okay, so you get the idea. You don't have to tell why, but you will have to say yes or no. Is it a poly or not? Okay, all right. So then the largest sum of the exponents in a term is the degree of the poly. That's super important. You have to be able to tell the degree of the polynomial because that will tell you how much work you have left to do. It's also going to tell you how many answers you have. Okay. The term that has the largest sum of the exponents is called the leading term. Now, so he's supposed to be in the front as the leader. Sometimes he's not. You have to rearrange him. Okay. the leading coefficient is just the number in front of this term, or the coefficient of the term mentioned there. Okay, so now we're just going to do some examples here. So first of all, it's going to ask, is it a poly, before we go any further. Then we're going to find the degree of the equation and the leading coefficient. Now be careful on this first one, because we said no radicals, but if you look closer, it says no variables under the radicals. So we can actually have a radical, we just can't have an x under it, okay? So this first one here, if you're looking through him, what you're looking for are really stinky exponents, like fractions and negatives. Then you're looking at the actual letters. Are the letters in the denominator? Are the letters under a radical? Okay, so what do we think? Is he a polynomial? He is. Yes, he's a poly. Okay, great. All right, then we want to know, what is the degree and what is the leading coefficient? Okay, degree is 5. Let's look at that. So all we did is we looked for the largest sum of exponents in a single term. So he doesn't even have any exponents, right? He has an exponent of 1. He has an exponent of 5. So 5's the biggest. So he's a degree 5. Or sometimes you'll hear me say he's a 5th degree. Okay, a 5th degree polynomial. All right, so now that we've narrowed down the degree, we're only going to look at that term. So what's the leading coefficient of that term only? A -3. See, I told you you guys would love this little section. Okay, good. All right, let's keep going here. We got the next guy. Oh my gosh. Okay, so find the degree and the leading coefficient and tell if it's a poly. Well, first of all, is this a poly? He is. He doesn't have anything weird going on. Okay, now, this may not look too bad, but then you look at the last one with a 10, and then you think, that's it. I'm calling the police. Ms. Holcomb has lost her mind. I'm not foiling this out 10 times, right? You'll be here the rest of your life. You do not have to write them 10 times and foil them out. There's a trick. Okay, there's a trick. So you're going to identify the exponent on every x. So he has an exponent of 3. What's his exponent? 1. Okay, now be careful here. This guy, his exponent's not 3 because he's got a 10 hanging out here. You're going to multiply those together. His exponent's actually going to be a 30. Now, we could still apply that to this guy in parentheses. He had a 1 out here, so we could say, okay, 1 times 1, that's where the 1 came from, if you want to, just to make sure you're good, okay? And then what you're going to do, bless you, is you're going to add the exponents, and that's going to give you the degree. So that only works if you have a bunch of stuff multiplied together. These weren't multiplied together, they were all added. But here, 3, this was 1 times 1, so he's 1. 3 times 10, so he's 30. 3 plus 1 plus 30, what degree is this? 34. Or if you just love math, you can write these 10 times and you can foil to your heart's content. Yeah, you're good. Okay, leading coefficient, all you're going to do is take the guy that's out front that you see. So he's a -2. Okay, all right. Now let's look at the next one. Is this guy a poly? Yeah. So far, so good. Okay. Now we got to be careful here. You may not have seen these before. You guys were rock stars with the 5th degree. But remember, the actual definition of a degree is the sum of the exponents in a term. Okay. So if I go down here, I realize there's more than one letter in each term. So I got to be careful. X has a 2, Y has a 1. So this term has an exponent of 3. I go to this term, X has a 1, Y has a 1. I'm only interested in the letters, not the numbers. Add them together, exponent on him is a 2. So what would be the degree of this poly? Which one's bigger? 3. This is a 3rd degree poly. Does that make sense? You pick the biggest one. Now here we had to add them all together, but that's because they were all multiplied together. And here we just took the 5 because there was nobody else with him. But here we had to add all the letters. Does that make sense? That's a little tricky. Okay. And then I'm going to look at his term. What's the leading coefficient for him? 2. Okay, awesome. All right, let's just finish this page then. Okay, so is this guy a poly? No, he's not. Why is he not a poly? Yeah, but why is that a problem? The variables in the bottom. The variables in the bottom. No, you don't have to find it. So if this were the poly, he would be a poly. This is a poly. You can have fractional coefficients. What you can't have is the letter in the bottom. So this is a no. You don't have to find anything. Okay, what about this guy? Why is he a no? Variable in the radical. Good. Okay, and then the last thing we're going to do is talk about this little sentence down here. So graphs of a polynomial, all right? What do they look like? They're smooth and continuous. It means no piecewise functions. You should be able to draw the whole graph without picking up your pencil, the whole thing. There's no sharp corners, okay? It's completely smooth. So nothing where you have to pick it up and go to another place. Nothing where it like juts out with a hard corner. It's gonna be smooth curves, okay? And then when we come back on Tuesday, we're going to talk about the behavior at each end, all the way to the left and all the way to the right. And that is called, believe it or not, end behavior. Okay. We're going to talk about how to look at the degree and the leading coefficient. There's a reason we're doing this. If you identify the degree and the coefficient, you can tell what it's doing on the end. All right, kiddos.
I don't think anyone paid attention to you to that.